Imagine stepping into a city where skyscrapers are not just buildings, but living, breathing ecosystems covered in lush greenery. Picture a world where entire communities float on water, adapting to rising sea levels and overcrowding with grace and innovation. What if your home could think for itself, adjusting to your needs and saving energy without you lifting a finger? This is not science fiction. This is the future of architecture, and it's closer than you think. In this video, we're diving into 25 groundbreaking concepts that are reshaping how we live, work, and interact with our environment. From vertical forests that purify the air to floating cities that defy the limits of land, these ideas are not just inspiring, they're transformative. They challenge us to rethink what's possible and push the boundaries of design, technology, and sustainability. By the end of this journey, you'll discover how architecture is evolving to meet the challenges of tomorrow, from climate change to urbanization, and how these innovations can inspire us to build a better, more connected world. So, if you're ready to explore the future of our built environment and uncover the ideas that will shape the way we live, let's dive in. The future is here, and it's waiting for you to imagine it. Now, let's take a closer look at our first concept, vertical forests. Imagine towering skyscrapers not just made of steel and glass, but wrapped in layers of vibrant greenery. These vertical forests are more than just architectural marvels. They're a bold response to the challenges of urban living. By integrating trees, shrubs, and plants directly into the design of buildings, these structures bring nature back into our cities in a way that's both functional and beautiful. One of the most compelling benefits of vertical forests is their ability to improve air quality. The plants act as natural filters, absorbing carbon dioxide and releasing oxygen, which helps combat pollution in densely populated areas. But the advantages don't stop there. These green skyscrapers also provide habitats for birds, insects, and other wildlife, creating pockets of biodiversity in the heart of urban landscapes. Aesthetically, vertical forests transform the skyline, turning concrete jungles into lush, living ecosystems. They offer a refreshing contrast to the monotony of traditional high-rises, blending modern design with the timeless beauty of nature. For residents, these buildings provide a unique living experience, with balconies and terraces filled with greenery that offer a sense of tranquility and connection to the natural world. Beyond their environmental and aesthetic appeal, vertical forests also address the growing need for sustainable urban development. As cities expand and green spaces shrink, these structures offer a creative solution to integrate nature into our daily lives. They challenge us to rethink how we design our cities, proving that architecture can be both innovative and eco-friendly. Vertical forests are more than just a trend. They're a glimpse into a future where nature and urban life coexist harmoniously. And as we continue to explore the possibilities of future architecture, this concept reminds us that the solutions to our challenges often lie in reconnecting with the natural world. Now let's set sail into our next concept, floating cities. Picture entire communities built not on solid ground, but on the vast, shimmering surface of the ocean. As rising sea levels and overcrowding threaten traditional urban spaces, floating cities emerge as a bold and innovative solution to these pressing challenges. These aquatic metropolises are not just a futuristic dream, they're a practical response to the realities of a changing world. One of the most significant advantages of floating cities is their ability to adapt to rising sea levels. Unlike traditional coastal cities which face the constant threat of flooding, these structures are designed to rise and fall with the tides, ensuring long-term resilience. This adaptability makes them an ideal solution for regions most vulnerable to climate change, offering a way to protect populations and infrastructure from the impacts of a warming planet. But floating cities are more than just a defense against environmental challenges. They're also a creative answer to urban overcrowding. With land becoming increasingly scarce, especially in densely populated areas, building on water opens up vast new possibilities for expansion. Imagine neighborhoods, parks, and even farms floating seamlessly on the ocean, connected by bridges and waterways. These cities could provide much-needed space for growing populations while reducing the strain on existing urban centers. Innovative designs are at the heart of making floating cities a reality. Architects and engineers are exploring cutting-edge materials and technologies to create stable, sustainable structures that can withstand the harsh conditions of the open water. From modular platforms that can be easily expanded to energy systems powered by waves and solar panels, these designs are pushing the boundaries of what's possible in urban development. Floating cities also offer unique opportunities for sustainability. By harnessing renewable energy sources like wind, solar, and tidal power, these communities could operate with minimal environmental impact. Some designs even incorporate underwater farms and marine habitats, creating a symbiotic relationship between the city and its aquatic surroundings. Aesthetically, floating cities promise to redefine our idea of urban beauty. Imagine sleek, modern structures reflecting off the water's surface, with green spaces and public areas that blend seamlessly with the natural environment. These cities could become iconic symbols of human ingenuity, showcasing our ability to adapt and thrive in harmony with nature. As we look to the future, floating cities represent more than just a solution to immediate challenges. They're a vision of what's possible when we rethink the way we live. By embracing innovation and sustainability, these aquatic communities could pave the way for a new era of urban design, one that's as resilient as it is inspiring. With floating cities, the future of architecture isn't just about building higher, it's about building smarter and in ways that respect the delicate balance of our planet. And as we continue our journey through these groundbreaking concepts, this idea reminds us that the solutions to our greatest challenges often lie in thinking beyond the boundaries of the familiar. Now, let's step into the future of living spaces with our next concept: smart homes powered by artificial intelligence. Imagine a home that doesn't just provide shelter, but actively works to make your life easier, more comfortable, and more sustainable. This is the promise of AI-integrated smart homes, where technology seamlessly blends with everyday living to create spaces that adapt to your needs in real time. At the heart of this revolution is the ability of artificial intelligence to learn and predict your preferences. Picture walking into a room where the lighting adjusts to your mood, the temperature sets itself to your ideal comfort level, and your favorite music starts playing, all without you lifting a finger. AI systems can analyze your habits and routines, tailoring the home environment to suit your lifestyle perfectly. This level of personalization not only enhances comfort but also reduces energy waste by optimizing resource use based on your actual needs. Energy efficiency is one of the most significant benefits of AI-driven smart homes. These systems can monitor and manage energy consumption in real time, automatically adjusting heating, cooling, and lighting to minimize waste. For example, if a room is unoccupied, the AI can turn off lights and lower the temperature, saving energy without requiring any input from you. Over time, these small adjustments can lead to substantial reductions in utility bills and a smaller carbon footprint, making smart homes a win for both your wallet and the planet. But the benefits don't stop there. AI can also enhance home security by integrating advanced surveillance and monitoring systems. Imagine a home that recognizes familiar faces, alerts you to unexpected visitors, and even locks doors automatically when you leave. These features provide peace of mind while ensuring that your home remains a safe and secure space for you and your family. Adaptability is another key feature of AI-integrated homes. As your needs change, so can your living space. For instance, if you start working from home more often, the AI can reconfigure your living room into a productive office environment with optimal lighting and minimal distractions. Or if you're hosting a gathering, the system can adjust the ambience to create a welcoming atmosphere for your guests. This flexibility ensures that your home evolves with you, meeting your needs at every stage of life. Aesthetically, smart homes can also be designed to blend technology with style. Sleek, minimalist interfaces and voice-activated controls replace clunky switches and remotes, creating a seamless and modern look. The integration of AI doesn't mean sacrificing design. It means enhancing it with technology that works quietly in the background to elevate your living experience. As we look ahead, smart homes with AI integration represent more than just a technological advancement. They're a shift in how we think about living spaces. By combining personalization, efficiency, and adaptability, these homes offer a glimpse into a future where our environments are not just places to live but active partners in our daily lives. With this concept, the future of architecture isn't just about building smarter homes, it's about creating spaces that truly understand and respond to us. And as we continue exploring these groundbreaking ideas, smart homes remind us that the future of living is as much about innovation as it is about connection. Now, let's shift our focus to a groundbreaking innovation that's reshaping the way we build: 3D printed architecture. Imagine constructing an entire building not with traditional bricks and mortar, but layer by layer using advanced printing technology. This isn't science fiction, it's a reality that's already transforming the construction industry, offering faster, more affordable, and more sustainable ways to create structures. At the core of 3D printed buildings is a process called additive manufacturing. Instead of cutting or shaping materials, this technology builds structures by depositing layers of material, often concrete or specialized composites based on a digital blueprint. Think of it like a giant printer, but instead of ink on paper, it's laying down walls, floors, and even intricate architectural details. This method allows for incredible precision and customization, enabling architects to bring even the most complex designs to life with ease. One of the most compelling advantages of 3D printed buildings is their cost-effectiveness. Traditional construction methods often involve significant labor costs, material waste, and lengthy timelines. With 3D printing, much of the manual labor is replaced by automated machines, reducing the need for large crews and cutting down on human error. Additionally, because the process uses only the exact amount of material needed, it minimizes waste, making it a more economical and environmentally friendly option. For example, some projects have reported material savings of up to 60% compared to conventional methods. Speed is another game-changing benefit. While traditional construction can take months or even years, 3D printed buildings can be completed in a fraction of the time. In some cases, entire homes have been printed in just 24 hours. This rapid construction capability is particularly valuable in addressing urgent housing needs, such as in disaster-stricken areas or rapidly growing urban centers. Imagine being able to provide safe, durable housing to communities in need almost overnight. This is the kind of impact 3D printing can have. Sustainability is a key driver behind the rise of 3D printed architecture. Beyond reducing material waste, this technology often incorporates eco-friendly materials, such as recycled concrete or biodegradable composites. Some projects even explore using locally sourced materials, further reducing the carbon footprint associated with transportation. Additionally, the precision of 3D printing allows for designs that optimize energy efficiency, such as walls with built-in insulation or structures that maximize natural light. These features make 3D printed buildings not just faster and cheaper to build, but also more sustainable in the long term. The potential applications of 3D printed architecture are vast. From affordable housing and emergency shelters to intricate custom homes and even large-scale commercial buildings, this technology is proving its versatility. In places like the Netherlands and the United States, entire neighborhoods of 3D printed homes are already being developed, showcasing the practicality and scalability of this approach. And as the technology continues to evolve, we can expect even more innovative uses, such as printing structures on other planets for space exploration. As we look to the future, 3D printed buildings represent more than just a new way to construct. They symbolize a shift toward smarter, more efficient, and more sustainable architecture. By combining cutting-edge technology with creative design, this concept is paving the way for a future where building faster, cheaper, and greener isn't just possible, it's the norm. And as we continue to explore the possibilities, one thing is clear: the future of construction is being printed one layer at a time. Now, let's turn our attention to a concept that sounds like it's straight out of a sci-fi movie but is very much a reality today: self-healing materials. Imagine a world where cracks in walls, bridges, or even roads can repair themselves without human intervention. This isn't just a dream, it's a revolutionary advancement in materials science that's already making waves in architecture and construction. Self-healing materials are designed to automatically repair damage, such as cracks or fractures, often through chemical or physical processes. One of the most common examples is self-healing concrete, which contains special bacteria or capsules of healing agents embedded within it. When a crack forms and water seeps in, these agents are activated, filling the gap and restoring the material's strength. This not only reduces the need for frequent repairs, but also significantly extends the lifespan of structures, saving time and money in the long run. The benefits of self-healing materials go beyond just cost savings. By minimizing the need for maintenance, these materials also reduce the environmental impact of construction. Fewer repairs mean less material waste and fewer resources spent on transportation and labor. For instance, self-healing asphalt is being tested in roads, where it can repair small cracks caused by weather or heavy traffic, preventing them from growing into larger potholes. This not only keeps roads in better condition, but also reduces the need for disruptive and resource-intensive roadwork. Another exciting application is in building facades and infrastructure. Imagine skyscrapers with self-healing coatings that can repair scratches or weather damage, or pipelines that can seal small leaks before they become major issues. These materials are already being used in some high-tech projects, such as bridges in the Netherlands that incorporate self-healing concrete to withstand harsh environmental conditions. The potential for these materials to enhance durability and safety is immense, especially in areas prone to extreme weather or seismic activity. But self-healing materials aren't limited to concrete and asphalt. Researchers are also exploring polymers and composites that can repair themselves. For example, some polymers can heal when exposed to heat or light, making them ideal for use in everything from windows to insulation. These materials could revolutionize how we think about maintenance, allowing structures to remain functional and aesthetically pleasing for decades with minimal intervention. As we look to the future, self-healing materials represent a significant step forward in creating more resilient and sustainable architecture. By reducing maintenance needs, extending the lifespan of structures, and minimizing environmental impact, these materials are paving the way for a future where buildings and infrastructure are not only smarter but also more durable. And as research continues to advance, we can expect even more innovative applications that will further transform the way we build and maintain our world. Now, let's shift our focus to a concept that's turning buildings into power plants: energy-generating facades. Picture a skyscraper that doesn't just consume energy but actually produces it, harnessing the power of the sun, wind, or even movement to meet its own needs and beyond. This isn't just a futuristic idea, it's a reality that's reshaping how we think about sustainable architecture. Energy-generating facades are designed to integrate renewable energy technologies directly into the building's exterior. One of the most common approaches is the use of solar panels embedded into the facade. These aren't your typical rooftop panels. They're sleek, often transparent or semi-transparent, and blend seamlessly with the building's design. For example, the Edge in Amsterdam, often called the world's most sustainable office building, features a facade covered in solar panels that generate enough energy to power the entire structure and even send excess energy back to the grid. But solar panels are just the beginning. Some buildings are incorporating wind turbines into their facades, especially in urban areas where wind patterns are unpredictable. These turbines are often small and designed to capture wind from any direction, making them ideal for high-rise buildings. The Bahrain World Trade Center, for instance, features 3 massive wind turbines integrated between its twin towers, generating a significant portion of the building's energy need. Another innovative approach is kinetic energy systems, which capture energy from movement. Imagine a facade made of panels that shift or vibrate in response to wind or even foot traffic. These movements can be converted into electricity, providing a continuous source of power. While still in the experimental phase, kinetic facades have the potential to turn everyday environmental forces into a reliable energy source. The benefits of energy-generating facades go beyond just sustainability. By producing their own energy, these buildings reduce reliance on external power grids, making them more resilient during outages or energy crises. They also lower operational costs over time, as the energy generated offsets utility bills. Plus, they contribute to a cleaner environment by reducing greenhouse gas emissions associated with traditional energy sources. As we look to the future, energy-generating facades represent a powerful step towards self-sufficient cities. By transforming buildings into active participants in energy production, we're not just reducing our carbon footprint, we're redefining the relationship between architecture and the environment. And as technology continues to advance, we can expect even more creative and efficient ways to integrate energy generation into the very fabric of our buildings. Now, let's take a journey beneath the surface to explore a concept that's as bold as it is practical: underground cities. As urban populations grow and available land becomes scarcer, architects and city planners are looking downward for solutions. Subterranean architecture offers a way to address both land scarcity and the challenges posed by a changing climate, creating spaces that are not only functional but also innovative and sustainable. Imagine entire cities built below ground, where streets, homes, offices, and even parks are nestled within the earth. These underground spaces can provide natural insulation, reducing the need for heating and cooling and making them incredibly energy efficient. For example, the Lowline Lab in New York City has demonstrated how underground parks can thrive using solar technology to channel natural light below the surface, creating lush, green spaces even in the depths of a metropolis. One of the most compelling reasons to explore underground cities is their ability to withstand extreme weather conditions. As climate change brings more frequent and intense storms, flooding, and heat waves, subterranean structures offer a level of protection that traditional above-ground buildings simply can't match. In cities like Singapore, where space is at a premium, underground developments are already being used to house utilities, transportation systems, and even shopping centers, freeing up valuable surface land for housing and green spaces. But underground cities aren't just about practicality, they're also about reimagining what urban life can look like. Futuristic designs envision multi-level subterranean communities connected by high-speed elevators and tunnels, with artificial lighting systems that mimic natural daylight. These spaces could include everything from residential neighborhoods to cultural hubs, all designed to feel open and inviting despite being underground. For instance, the proposed underground city in Helsinki aims to create a network of tunnels and caverns that house everything from swimming pools to data centers, blending functionality with cutting-edge design. Of course, building underground comes with its own set of challenges, from engineering complexities to ensuring proper ventilation and lighting. However, advancements in technology are making these obstacles easier to overcome. Innovations like 3D mapping and robotic excavation are enabling architects to design and construct underground spaces with greater precision and efficiency than ever before. As we look to the future, underground cities represent a fascinating blend of necessity and creativity. By tapping into the potential of subterranean architecture, we can create resilient, sustainable urban environments that adapt to the challenges of our time. And as these designs continue to evolve, they may just redefine what it means to live, work, and thrive in the cities of tomorrow. Now, let's step into a world where architecture and nature intertwine in the most harmonious way. Biophilic design is more than just a trend. It's a transformative approach that brings the outdoors inside, creating spaces that nurture both the mind and body. By integrating natural elements like plants, water features, and natural light, biophilic design seeks to reconnect us with the environment, even in the heart of bustling cities. The benefits of biophilic design go far beyond aesthetics. Studies have shown that incorporating nature into our built environments can significantly reduce stress, boost creativity, and improve overall well-being. Imagine walking into an office where living walls of greenery greet you, or a hospital where sunlight streams through large windows, creating a calming atmosphere for patients and staff alike. These aren't just beautiful spaces, they're healing ones. One standout example is the Amazon Spheres in Seattle, a workplace designed to feel like a rainforest. With thousands of plants, flowing water features, and natural light filtering through glass domes, the spheres offer employees a serene escape from the typical office environment. The result: increased productivity, higher job satisfaction, and a stronger connection to nature, even in an urban setting. Another inspiring project is the Bosco Verticale in Milan, a pair of residential towers covered in trees and shrubs. These vertical forests not only provide residents with stunning views and cleaner air, but also serve as a model for how cities can integrate nature into high-density living. By blending architecture with ecology, biophilic design creates spaces that are as functional as they are beautiful. But biophilic design isn't just for large-scale projects. Even small changes like adding indoor plants, using natural materials like wood and stone, or designing spaces with ample sunlight can make a big difference. For instance, schools that incorporate biophilic principles often see improved focus and academic performance among students, proving that nature has a profound impact on our ability to learn and thrive. As we look to the future, biophilic design offers a powerful way to address some of the challenges of modern urban life. By prioritizing our connection to nature, we can create spaces that promote mental health, foster creativity, and enhance our quality of life. Whether it's a towering skyscraper or a cozy home, biophilic design reminds us that the best architecture doesn't just shelter us, it inspires and rejuvenates us. Now, let's shift our focus to a concept that's revolutionizing the way we think about housing: modular and prefabricated homes. Imagine a future where building a home is as simple as assembling pieces of a puzzle. Modular construction is making this a reality by offering faster, more affordable, and highly customizable housing solutions. This innovative approach involves constructing sections of a home or modules in a factory setting, then transporting and assembling them on site. The result: a streamlined process that cuts down on construction time and costs while maintaining high-quality standards. One of the most significant advantages of modular homes is speed. Traditional construction can take months or even years, but modular homes can be completed in a matter of weeks. Since the modules are built indoors, weather delays are virtually eliminated, and the controlled factory environment ensures precision and efficiency. For example, a family in need of a new home could move in just a few months after placing their order, compared to the lengthy timelines of conventional building methods. Affordability is another key benefit. By optimizing materials and reducing waste, modular construction significantly lowers costs. Factory production allows for bulk purchasing of materials and minimizes errors, which translates to savings for homeowners. Additionally, the reduced construction time means lower labor costs. This makes modular homes an attractive option for first-time buyers, growing families, or anyone looking for a cost-effective housing solution without compromising on quality. But modular homes aren't just practical, they're also highly customizable. From sleek, modern designs to cozy, traditional layouts, the possibilities are nearly endless. Homeowners can work with architects and designers to create a space that perfectly suits their needs and preferences. Some companies even offer eco-friendly options, incorporating sustainable materials and energy-efficient systems to reduce the home's environmental footprint. This level of personalization ensures that modular homes are as unique as the people living in them. A great example of modular construction in action is the Casita project in Austin, Texas. These compact, stylish homes are designed for urban living, offering all the amenities of a traditional house in a smaller, more efficient footprint. With features like smart home technology and customizable interiors, Casita demonstrates how modular design can adapt to the needs of modern life. Similarly, in Sweden, modular homes are being used to address housing shortages, providing quick and affordable solutions for families in need. As we look ahead, modular and prefabricated homes have the potential to address some of the most pressing challenges in housing today. From reducing construction waste to making homeownership more accessible, this approach is reshaping the way we live. Whether it's a single-family home, a multi-unit development, or even emergency housing, modular construction offers a versatile and sustainable solution for the future. By embracing this innovative method, we can create homes that are not only faster and more affordable, but also tailored to the unique needs of their inhabitants. Now, let's take a leap into the future of urban mobility with Hyperloop-inspired transportation hubs. Picture a world where traveling between cities feels as quick and seamless as hopping on a subway. Hyperloop technology, with its high-speed pods traveling through low-pressure tubes, promises to revolutionize how we move. But it's not just about speed, it's about how this innovation will reshape the very design of our cities and the hubs that connect them. Imagine stepping into a transportation hub that feels more like a futuristic airport than a traditional train station. These hubs will be designed to handle the rapid flow of passengers, integrating Hyperloop systems with other modes of transit like buses, bikes, and autonomous vehicles. The goal: to create a seamless, multimodal experience where travelers can switch between different forms of transportation effortlessly. For instance, you could arrive at a Hyperloop hub, step off a pod, and within minutes, board an autonomous shuttle to your final destination, all without the usual delays or hassles. One of the most exciting aspects of Hyperloop hubs is their potential to redefine urban connectivity. By drastically reducing travel times between cities, these hubs could turn distant regions into accessible extensions of urban centers. Think about it, a Hyperloop system could connect cities hundreds of miles apart in under an hour, effectively shrinking the map. This could lead to the rise of mega-regions, where people live in one city but work or study in another, all made possible by the efficiency of Hyperloop travel. Design-wise, Hyperloop hubs will prioritize sustainability and innovation. Architects are already envisioning hubs powered by renewable energy, with sleek, aerodynamic designs that reflect the cutting-edge technology they house. Solar panels, green roofs, and energy-efficient lighting could become standard features, making these hubs not just transit points but also symbols of a greener future. Some concepts even include vertical gardens and public spaces, transforming hubs into community gathering spots rather than mere transportation nodes. A great example of this vision is the proposed Hyperloop hub in Dubai. Designed to be a central node in the city's ambitious Hyperloop network, This hub would integrate with existing infrastructure while offering futuristic amenities like AI-driven navigation and real-time updates. It's a glimpse into how Hyperloop technology could elevate urban design, blending functionality with aesthetics to create spaces that inspire. As we look ahead, Hyperloop-inspired transportation hubs have the potential to transform not just how we travel, but how we live. By bringing cities closer together and reimagining the spaces that connect them, this technology could pave the way for a more interconnected and sustainable future. Whether it's reducing commute times, easing urban congestion, or fostering regional collaboration, Hyperloop hubs represent a bold step forward in the evolution of our cities. And as these hubs become a reality, they'll remind us that the future of transportation isn't just about getting from point A to point B. It's about creating a world where distance no longer limits our possibilities. Now, let's shift our focus to a concept that's not just about building for the future, but doing so responsibly: carbon-neutral buildings. As the world grapples with climate change, the architecture industry is stepping up with designs that aim to leave no carbon footprint behind. These structures are more than just eco-friendly. They're a bold statement of how we can live in harmony with our planet. At the heart of carbon-neutral buildings is the use of sustainable materials. Think timber, bamboo, and recycled steel materials that are not only durable, but also have a significantly lower environmental impact compared to traditional concrete and steel. For example, cross-laminated timber is gaining popularity as a strong, renewable alternative that stores carbon rather than emitting it. By choosing materials like these, architects are reducing the carbon emissions associated with construction while creating spaces that feel warm and natural. But it's not just about the materials, it's also about how these buildings operate. Carbon-neutral designs often incorporate advanced energy systems that minimize reliance on fossil fuels. Solar panels, wind turbines, and geothermal heating are just a few examples of how these buildings generate their own clean energy. Some even go a step further by integrating smart technology to optimize energy use, ensuring that every watt is used efficiently. Imagine a building that adjusts its lighting, heating, and cooling based on real-time data, all while maintaining comfort for its occupants. Design principles also play a crucial role in achieving carbon neutrality. Passive design strategies, such as maximizing natural light and ventilation, reduce the need for artificial lighting and air conditioning. Green roofs and walls not only insulate buildings but also absorb carbon dioxide, making them a double win for sustainability. Architects are also exploring modular designs that allow for easier disassembly and recycling, ensuring that buildings can adapt or be repurposed without generating waste. A standout example of carbon-neutral architecture is the Bullitt Center in Seattle, often referred to as the greenest commercial building in the world. This 6-story structure generates all its own energy through solar panels, collects and treats its own water, and uses composting toilets to minimize waste. It's a living proof that carbon-neutral buildings aren't just a concept, they're a reality that's reshaping the way we think about construction. As we look to the future, carbon-neutral buildings represent a critical step toward a more sustainable world. They challenge us to rethink not just how we build, but how we live. By prioritizing materials, energy systems, and designs that minimize environmental impact, these structures are setting a new standard for architecture, one that balances innovation with responsibility. And as more of these buildings rise, they'll serve as a reminder that the future of architecture isn't just about what we create, but how we create it. Now, let's explore a concept that bridges the past and the future: adaptive reuse of structures. This innovative approach takes existing buildings and transforms them into something entirely new, preserving their historical charm while meeting the demands of modern life. It's a powerful way to honor our architectural heritage while addressing the challenges of urban development and sustainability. Adaptive reuse is all about creativity and resourcefulness. Instead of tearing down old buildings, architects and designers reimagine them for new purposes. Think of an abandoned factory turned into a vibrant office space, or a historic church transformed into a community center. These projects breathe new life into structures that might otherwise be forgotten, giving them a second chance to serve their communities. One of the most compelling aspects of adaptive reuse is its environmental benefits. By repurposing existing buildings, we reduce the need for new construction materials, which in turn cuts down on waste and carbon emissions. It's a sustainable alternative to demolition, which often generates tons of debris and consumes significant energy. Plus, preserving older structures helps maintain the character and identity of neighborhoods, creating a sense of continuity in rapidly changing urban landscapes. But adaptive reuse isn't just about sustainability, it's also about storytelling. These projects allow us to connect with the past, preserving the history and memories embedded in the walls of old buildings. For example, the High Line in New York City, once an abandoned railway, is now a beloved elevated park that tells the story of the city's industrial past while providing a green oasis for residents and visitors alike. It's a perfect blend of history, innovation, and community. Of course, adaptive reuse comes with its own set of challenges. Older buildings often require significant upgrades to meet modern safety and accessibility standards. Architects must carefully balance preserving the original character of the structure with incorporating contemporary features. This can involve everything from reinforcing foundations to installing energy-efficient systems, all while maintaining the building's unique aesthetic. A standout example of adaptive reuse is the Tate Modern in London. What was once a disused power station is now one of the world's most iconic art museums. The transformation retained the building's industrial grandeur while creating a space that's both functional and inspiring. It's a testament to how adaptive reuse can turn the ordinary into the extraordinary. As cities continue to grow and evolve, adaptive reuse offers a way to honor the past while embracing the future. It's a reminder that innovation doesn't always mean starting from scratch. Sometimes, the most groundbreaking ideas come from reimagining what's already there. By giving old buildings new purpose, we're not just preserving history, we're building a more sustainable and meaningful future. Now, let's shift our focus to a concept that merges cutting-edge technology with everyday functionality: transparent solar panels. Imagine a world where the windows of your home or office not only let in natural light but also generate clean energy. This is the promise of transparent solar technology, a revolutionary innovation that could redefine how we think about energy and architecture. Transparent solar panels work by allowing visible light to pass through while capturing ultraviolet and infrared light, which is then converted into electricity. This means that glass surfaces like windows or building facades can become active energy generators without sacrificing their transparency or aesthetic appeal. It's a seamless integration of form and function, blending sustainability with modern design. One of the most exciting aspects of this technology is its versatility. Transparent solar panels can be incorporated into skyscrapers, homes, greenhouses, and even vehicles. For instance, a high-rise building covered in energy-generating windows could significantly reduce its reliance on external power sources, making it more self-sufficient and environmentally friendly. Similarly, greenhouses equipped with transparent solar panels could grow crops while simultaneously producing energy, creating a dual-purpose solution for sustainable agriculture. The environmental benefits are undeniable. By turning everyday surfaces into energy sources, transparent solar panels can help reduce our dependence on fossil fuels and lower carbon emissions. They also minimize the need for additional land or space, as they utilize existing structures rather than requiring separate installations like traditional solar farms. This makes them an ideal solution for urban environments where space is at a premium. But what about the aesthetics? One of the biggest challenges in renewable energy has been balancing functionality with design. Traditional solar panels, while effective, can be bulky and visually intrusive. Transparent solar panels, on the other hand, are virtually invisible, allowing architects to maintain the sleek, modern look of their designs. This opens up new possibilities for integrating renewable energy into iconic buildings without compromising their visual appeal. A great example of this technology in action is the Michigan State University's Biomedical and Physical Sciences building, which features transparent solar panels integrated into its windows. These panels not only generate electricity, but also serve as a testament to how innovation can enhance both sustainability and design. It's a glimpse into a future where every glass surface could contribute to a cleaner, greener planet. Of course, there are still challenges to overcome. The efficiency of transparent solar panels is currently lower than that of traditional panels, and the technology is still in its early stages of development. However, ongoing research and advancements are steadily improving their performance, making them a promising option for the future of energy and architecture. As we look ahead, transparent solar panels represent a bold step toward a more sustainable and visually harmonious world. They remind us that the future of architecture isn't just about building new structures, it's about reimagining the potential of what already exists. By turning everyday surfaces into sources of clean energy, we're not just designing buildings, we're shaping a brighter, more sustainable future. Now, let's step into the realm of smart cities, where the Internet of Things is transforming urban landscapes into interconnected hubs of efficiency and innovation. Imagine a city where every streetlight, traffic signal, and public transport system communicates seamlessly, creating a network that responds in real time to the needs of its residents. This is the vision of smart cities powered by the Internet of Things, a concept that promises to revolutionize how we live, work, and interact with our surroundings. At the heart of this transformation is the ability to collect and analyze vast amounts of data from countless connected devices. Sensors embedded in infrastructure, vehicles, and even household appliances gather information on everything from energy usage to traffic patterns. This data is then processed and used to optimize city operations, making them more efficient and sustainable. For example, smart traffic management systems can adjust signal timings based on real-time traffic flow, reducing congestion and cutting down on emissions. Similarly, smart grids can balance energy supply and demand, ensuring that power is distributed efficiently and reducing waste. One of the most exciting aspects of smart cities is their potential to improve quality of life. Imagine a city where waste collection is scheduled based on how full bins are, or where streetlights dim automatically when no one is around, saving energy without compromising safety. Public services can become more responsive and personalized, with apps that notify residents of the nearest available parking spot or the fastest route to their destination. Even healthcare can benefit with wearable devices that monitor health metrics and alert medical professionals in case of emergencies. But the benefits of smart cities go beyond convenience. By optimizing resource use, these interconnected systems can significantly reduce environmental impact. For instance, water management systems can detect leaks in real time, preventing waste and conserving this precious resource. Energy-efficient buildings equipped with smart thermostats and lighting systems can adapt to occupancy and weather conditions, minimizing energy consumption. These innovations not only lower costs but also contribute to a more sustainable future. Of course, building a smart city is no small feat. It requires significant investment in infrastructure, as well as robust cybersecurity measures to protect the vast amounts of data being collected. Privacy concerns also need to be addressed, as the constant flow of information raises questions about how data is used and who has access to it. However, with careful planning and collaboration between governments, businesses, and citizens, these challenges can be overcome. A shining example of this vision in action is Singapore, often hailed as one of the world's leading smart cities. Through initiatives like its Smart Nation program, the city-state has integrated EOT technology into everything from public transportation to healthcare, creating a model for urban innovation. Residents enjoy streamlined services, reduced environmental impact, and an overall higher quality of life, showcasing the potential of smart cities to transform urban living. As we look to the future, the possibilities of smart cities are truly limitless. By harnessing the power of the Internet of Things, we can create urban environments that are not only more efficient and sustainable, but also more livable and inclusive. It's a vision that challenges us to rethink what cities can be, turning them into dynamic ecosystems that adapt and evolve to meet the needs of their inhabitants. The smart city is more than just a concept, it's a blueprint for a better, more connected world. Now, let's shift our focus to a concept that brings movement and adaptability to the very fabric of architecture, kinetic architecture. Picture a building that isn't static but alive, responding to its surroundings with moving parts that adjust to environmental conditions. This is the essence of kinetic architecture, where structures are designed to transform, offering both functionality and a dynamic visual experience. At its core, kinetic architecture is about creating buildings that can adapt to changing needs and conditions. Imagine a skyscraper with rotating floors that shift throughout the day to maximize sunlight or minimize heat exposure. Or consider a stadium with a retractable roof that opens to welcome natural light and fresh air during events, then closes to protect against rain or harsh weather. These designs aren't just about aesthetics, they're about enhancing efficiency, comfort, and sustainability. One of the most fascinating aspects of kinetic architecture is its ability to respond to environmental challenges. For instance, buildings in areas prone to extreme weather can incorporate moving facades or adjustable shading systems to protect against storms or intense sunlight. In urban environments, kinetic elements like foldable balconies or expandable walls can optimize space usage, making the most of limited real estate. This adaptability not only improves the functionality of buildings, but also reduces their environmental footprint by minimizing energy consumption. The technology behind kinetic architecture is equally impressive. Advanced materials, sensors, and automation systems work together to enable seamless movement. For example, lightweight yet durable materials like carbon fiber allow for large-scale moving parts without compromising structural integrity. Sensors can detect changes in temperature, wind, or light, triggering adjustments in real time. And automation ensures that these transformations happen smoothly and efficiently, often without the need for human intervention. A standout example of kinetic architecture is the Al Bahar Towers in Abu Dhabi. These towers feature a dynamic facade made up of hundreds of hexagonal panels that open and close in response to the sun's movement. This innovative design reduces solar heat gain by up to 50%, significantly lowering the building's cooling needs and energy consumption. It's a perfect blend of form and function, showcasing how kinetic architecture can address both environmental and aesthetic goals. But the potential of kinetic architecture goes beyond individual buildings. Imagine entire cityscapes where structures adapt collectively to changing conditions. For example, a network of kinetic buildings could work together to manage urban heat islands by adjusting their facades to reflect or absorb heat as needed. Or consider the possibilities for disaster resilience, with buildings that can reconfigure themselves to withstand earthquakes or floods. The applications are as vast as our imagination. Of course, designing and constructing kinetic buildings comes with its own set of challenges. The complexity of moving parts requires meticulous engineering and maintenance to ensure long-term reliability. Costs can also be higher compared to traditional architecture, though the long-term savings in energy and resource efficiency often justify the investment. As technology continues to advance, these challenges are likely to diminish, making kinetic architecture more accessible and widespread. Kinetic architecture represents a bold step forward in how we think about the built environment. It challenges the notion that buildings must be static, instead envisioning them as dynamic, responsive entities that evolve with their surroundings. By embracing movement and adaptability, we can create spaces that are not only more efficient and sustainable, but also more engaging and inspiring. It's a vision of architecture that moves literally and figuratively toward a smarter, more flexible future. Now, let's step into a world where the boundaries between the physical and digital realms blur. Holographic displays in public spaces. Picture walking through a city square where towering holograms of art installations shift and change before your eyes, or waiting at a bus stop where real-time transit updates float in the air, visible from every angle. This is the future of public spaces, where holographic technology transforms how we interact with our surroundings. Holographic displays are more than just futuristic eye candy. They're a powerful tool for communication, engagement, and creativity. Imagine a park where children play with holographic animals that respond to their movements, or a museum where historical figures come to life, sharing their stories in vivid detail. These experiences aren't just entertaining, they're educational, immersive, and deeply memorable. Holograms have the potential to turn ordinary spaces into dynamic environments that captivate and inspire. One of the most exciting applications of holographic technology is in real-time information displays. Think about how useful it would be to have holographic maps in busy train stations, guiding passengers with clear, three-dimensional directions. Or consider public announcements that appear as floating text, visible to everyone without the need for screens or speakers. This technology could revolutionize how we navigate and interact with urban spaces, making information more accessible and intuitive. Art and culture also stand to benefit immensely from holographic displays. Public art installations could become interactive experiences, changing based on the time of day, weather, or even the mood of the crowd. Imagine a holographic sculpture that shifts colors and shapes as people walk by, creating a unique experience for every visitor. This fusion of art and technology could redefine how we experience creativity in public spaces, making it more inclusive and engaging. The potential for holographic displays extends to entertainment as well. Outdoor concerts could feature holographic performers, bringing legendary artists back to the stage or creating entirely new virtual acts. Sports stadiums could use holograms to enhance the viewing experience, projecting replays or statistics in mid-air for the entire audience to see. The possibilities are endless, limited only by our imagination and the pace of technological advancement. Of course, integrating holographic displays into public spaces comes with its own set of challenges. The technology requires significant energy and infrastructure, and ensuring accessibility for all users is crucial. Privacy concerns also arise, as holograms could potentially collect data or display unwanted content. However, as the technology evolves, these challenges are likely to be addressed, paving the way for widespread adoption. Holographic displays represent a bold leap forward in how we design and experience public spaces. They offer a new way to blend the physical and digital worlds, creating environments that are not only functional but also magical. By embracing this technology, we can transform ordinary spaces into extraordinary ones, fostering connection, creativity, and wonder. It's a vision of the future where the line between reality and imagination becomes beautifully blurred. Now, let's take a giant leap beyond our planet and explore the fascinating world of space architecture. Imagine designing habitats not just for Earth, but for the Moon, Mars, and beyond. Space architecture is about creating structures that can withstand the harsh conditions of outer space while providing safe, functional, and even comfortable living environments for astronauts and future space colonists. One of the most exciting developments in this field is the design of lunar bases. These bases are envisioned as self-sustaining habitats that can support long-term human presence on the moon. Picture domed structures made from lightweight, durable materials powered by solar energy and equipped with advanced life support systems. These bases would not only serve as research stations but also as stepping stones for deeper space exploration. The challenges of building on the moon, extreme temperatures, lack of atmosphere, and limited resources push architects and engineers to innovate in ways that could revolutionize construction techniques back on Earth. Mars colonies take this concept even further. Designing habitats for the Red Planet involves addressing issues like radiation protection, low gravity, and the need for sustainable food and water sources. One proposed solution is the use of 3D printed structures made from Martian soil, which would reduce the need to transport heavy building materials from Earth. These habitats could feature underground living spaces to shield inhabitants from radiation, with greenhouses and water recycling systems to create a closed-loop ecosystem. The lessons learned from designing for Mars could inspire more sustainable and resilient architecture on our own planet. Space architecture also has profound implications for Earth-based design. The need for energy efficiency, resource conservation, and compact living in space habitats can translate into innovative solutions for urban environments. For example, the use of modular construction and prefabricated components, essential for space habitats, could make housing more affordable and adaptable on Earth. Similarly, the emphasis on self-sustaining systems in space could drive advancements in renewable energy and waste management technologies for terrestrial use. Another intriguing aspect of space architecture is its focus on human well-being in extreme environments. Designing habitats that promote mental and physical health in the isolation of space could lead to new insights into creating healthier living and working environments on Earth. Features like natural lighting, biophilic design, and flexible spaces that adapt to different activities could become standard in future homes and offices. As we look to the stars, space architecture reminds us that the principles of good design are universal. Whether on Earth or in space, the goal is to create environments that are functional, sustainable, and inspiring. By pushing the boundaries of what's possible in the cosmos, we can bring those innovations back home, shaping a better future for architecture and humanity alike. The journey into space architecture is not just about exploring new worlds, it's about reimagining our own. Now, shifting our focus back to Earth, let's explore the concept of zero-waste construction, a revolutionary approach that's reshaping how we build our cities and homes. Imagine a world where every piece of material used in construction has a purpose and nothing goes to waste. This isn't just a dream, it's a growing reality, thanks to innovative methods that prioritize sustainability and efficiency. One of the key strategies in zero-waste construction is the use of recycled materials. Instead of relying solely on new resources, architects and builders are turning to reclaimed wood, recycled steel, and even repurposed concrete. These materials not only reduce the demand for virgin resources, but also cut down on the energy and emissions associated with producing new building components. For example, some projects are using crushed concrete from demolished buildings as a base for new structures, creating a closed-loop system that minimizes waste. Another groundbreaking approach is the adoption of circular economy principles in construction. Unlike the traditional linear model of take, make, dispose, the circular economy focuses on keeping materials in use for as long as possible. This means designing buildings with disassembly in mind, so that components can be reused or recycled at the end of their life cycle. Modular construction plays a big role here, as prefabricated units can be easily taken apart and reassembled elsewhere, reducing waste and extending the lifespan of materials. Innovative technologies are also driving the zero-waste movement. For instance, 3D printing is being used to create precise building components with minimal material waste. By layering materials exactly where they're needed, this technology eliminates the excess that often comes with traditional construction methods. Additionally, digital tools like Building Information Modeling or BIM allow architects to optimize material usage during the design phase, ensuring that every piece serves a purpose. Beyond materials and technology, zero-waste construction also involves rethinking construction processes. On-site waste management systems are being implemented to sort and recycle debris, while partnerships with local recycling facilities ensure that materials are properly processed. Some projects are even experimenting with bio-based materials such as mycelium bricks or hempcrete, which are not only sustainable but also biodegradable. The benefits of zero-waste construction extend far beyond environmental impact. By reducing waste, builders can lower costs, improve efficiency, and create healthier living spaces. This approach also aligns with the growing demand for sustainable practices, making it a win-win for both the planet and the construction industry. As we look to the future, zero-waste construction offers a blueprint for building smarter and more responsibly. By embracing recycled materials, circular economy principles, and cutting-edge technologies, we can create structures that are not only functional and beautiful but also kind to the earth. This concept reminds us that every brick, beam, and bolt has the potential to contribute to a more sustainable world. And with that, let's move forward to explore another inspiring idea in the realm of future architecture. Now, let's turn our attention to a concept that's becoming increasingly vital in our changing world: climate-responsive design. As extreme weather events become more frequent and intense, architects are reimagining how buildings can adapt to these challenges, ensuring they remain safe, functional, and sustainable. This approach isn't just about survival, it's about creating spaces that thrive in harmony with their environment. One of the most striking examples of climate-responsive design is flood-resistant architecture. In regions prone to heavy rainfall or rising sea levels, homes and buildings are being elevated on stilts or designed with waterproof materials. Some structures even incorporate floating foundations, allowing them to rise with floodwaters without sustaining damage. For instance, in the Netherlands, architects have pioneered amphibious homes that float during floods and settle back into place once the waters recede. These innovative designs not only protect property but also provide peace of mind for residents living in vulnerable areas. Heat-deflecting materials are another game-changer in climate-responsive design. In areas experiencing scorching temperatures, buildings are being constructed with reflective surfaces, insulated walls, and advanced ventilation systems to keep interiors cool. Materials like cool roofs, which reflect sunlight rather than absorb it, are becoming increasingly popular. These roofs can significantly reduce indoor temperatures, cutting down on the need for energy-intensive air conditioning. Similarly, architects are incorporating natural shading elements such as overhangs and strategically placed vegetation to block direct sunlight and create cooler microclimates around buildings. But climate-responsive design goes beyond individual materials or techniques. It's about a holistic approach to building. For example, some architects are designing structures that can adapt to seasonal changes. In colder climates, buildings might feature south-facing windows to maximize sunlight during winter, while in warmer regions, deep eaves and shaded courtyards help keep interiors cool year-round. These thoughtful design choices not only enhance comfort but also reduce energy consumption, making buildings more sustainable in the long run. Another exciting development is the use of smart technology in climate-responsive architecture. Sensors and automated systems can monitor weather conditions in real time, adjusting a building's features to respond accordingly. Imagine windows that tint automatically to block intense sunlight or ventilation systems that activate during heat waves to maintain optimal airflow. These technologies not only improve resilience but also create a more dynamic and interactive relationship between buildings and their environment. the benefits of climate-responsive design extend far beyond practicality. By integrating these principles, architects are creating spaces that are not only resilient but also deeply connected to their surroundings. This approach fosters a sense of harmony between human-made structures and the natural world, reminding us that architecture can be both functional and beautiful. As we continue to face the challenges of a changing climate, climate-responsive design offers a powerful solution. It's a reminder that with creativity and innovation, we can build structures that not only withstand the elements but also enhance our quality of life. And with that, let's move forward to explore yet another inspiring concept in the world of future architecture. Now, let's step into a world where imagination meets reality, augmented reality in design and construction. This groundbreaking technology is transforming the way architects bring their visions to life and how clients experience those visions before a single brick is laid. Augmented reality, or AR, overlays digital elements onto the real world, creating an immersive experience that bridges the gap between concept and reality. Imagine walking through a building that hasn't even been constructed yet. With AR, architects can project 3D models of their designs onto physical spaces, allowing clients to explore every detail in real time. This isn't just a static blueprint, it's a dynamic, interactive experience. Clients can walk through virtual hallways, adjust lighting, or even change materials with a simple gesture. This level of engagement not only helps clients understand the design better, but also empowers them to make informed decisions early in the process, reducing costly changes later on. For architects, AR is a game changer in the design phase. Instead of relying solely on 2D drawings or computer screens, they can now visualize their creations in the actual environment where they'll be built. This allows for more accurate planning and problem solving. For example, an architect can use AR to see how a new skyscraper will interact with its surroundings, ensuring it complements the skyline rather than disrupting it. They can also identify potential issues like structural conflicts or spatial inefficiencies before construction begins, saving time and resources. But the benefits of AR don't stop at design. During construction, AR can guide workers by overlaying precise instructions onto the physical site. Imagine a construction worker wearing AR glasses that show exactly where to place a beam or how to align a wall. This not only improves accuracy but also speeds up the building process, reducing delays and errors. It's like having a digital blueprint that comes to life right before your eyes. One of the most exciting aspects of AR is its ability to democratize architecture. Traditionally, only professionals could fully understand complex designs, but AR makes architecture accessible to everyone. Clients, stakeholders, and even the general public can experience and engage with designs in a way that's intuitive and immersive. This fosters collaboration and ensures that everyone involved has a clear understanding of the project's vision. As we look to the future, the potential of AR in architecture is limitless. From creating hyper-realistic virtual walkthroughs to enabling real-time design adjustments, this technology is redefining how we think about space and construction. It's not just a tool, it's a new way of seeing and shaping the world around us. And with that, let's move forward to uncover another inspiring concept that's shaping the future of architecture. Now, let's shift our focus to a concept that blurs the line between architecture and biology living buildings. Imagine structures that don't just stand still but grow, adapt, and evolve over time. This isn't science fiction, it's the future of architecture where buildings are designed to be alive in every sense of the word. Living buildings are made possible through bioengineered materials and self-sustaining ecosystems. These materials are not just static components, they are dynamic, capable of responding to their environment. For example, imagine walls that can heal themselves when damaged, or surfaces that change color to regulate temperature based on the weather. These innovations are inspired by nature, where adaptability and resilience are key to survival. One of the most fascinating aspects of living buildings is their ability to integrate with natural ecosystems. Picture a skyscraper covered in bioengineered algae panels that absorb carbon dioxide and produce oxygen, effectively acting as a giant air purifier. Or envision a building with a living roof that grows plants, filters rainwater, and provides habitat for local wildlife. These structures don't just coexist with nature, they actively contribute to it, creating a harmonious balance between the built environment and the natural world. But how do these buildings grow and evolve? The answer lies in advanced materials and technologies. Bioengineered materials such as self-repairing concrete or photosynthetic coatings allow buildings to maintain themselves and even improve over time. Meanwhile, integrated systems monitor the building's health, adjusting its functions to optimize energy use, air quality, and structural integrity. It's like having a building with its own immune system, constantly adapting to ensure it remains functional and efficient. Living buildings also have the potential to revolutionize sustainability. By mimicking natural processes, they can reduce waste, conserve resources, and even generate their own energy. For instance, a living building might use microbial fuel cells to convert organic waste into electricity, or employ biofilters to clean water for reuse. These innovations not only make buildings more sustainable but also reduce their environmental footprint, paving the way for a greener future. As we look ahead, the possibilities for living buildings are endless. From urban skyscrapers that breathe and grow to homes that adapt to the needs of their inhabitants, this concept is redefining what it means to build. It's not just about creating spaces, it's about creating life. And with that, let's explore another groundbreaking idea that's shaping the future of architecture. Now, let's turn our attention to a concept that's reshaping the way we think about food production in cities' vertical farming skyscrapers. As urban populations continue to grow, the demand for fresh, locally sourced food is skyrocketing. But with limited space in cities, traditional farming methods simply can't keep up. That's where vertical farming comes in, offering a revolutionary solution by bringing agriculture into the heart of urban landscapes. Vertical farming skyscrapers are exactly what they sound like: towering structures designed to grow crops on multiple levels, often using advanced technologies like hydroponics, aeroponics, and controlled environment agriculture. These systems allow plants to thrive without soil, using nutrient-rich water or mist, and are carefully monitored to optimize light, temperature, and humidity. The result, a highly efficient way to produce food year-round, regardless of the weather outside. One of the most significant benefits of vertical farming is its ability to address food security. By growing food closer to where people live, these skyscrapers reduce the need for long-distance transportation, which not only cuts down on emissions but also ensures fresher produce reaches consumers. Imagine walking into a grocery store and picking up lettuce that was harvested just hours ago from a farm a few blocks away. This localized approach to agriculture can help cities become more self-sufficient, reducing reliance on distant farms and vulnerable supply chains. Another advantage is the dramatic reduction in land use. Traditional farming requires vast expanses of land, which is increasingly scarce in urban areas. Vertical farming, on the other hand, maximizes space by stacking crops vertically, allowing a single skyscraper to produce the equivalent of hundreds of acres of farmland. This is especially important as cities expand and arable land becomes more limited. Plus, by growing food indoors, vertical farms are protected from pests and extreme weather, reducing the need for harmful pesticides and ensuring consistent yield. But the benefits don't stop there. Vertical farming skyscrapers also have the potential to significantly lower transportation emissions. Currently, a large portion of the food we consume travels hundreds or even thousands of miles to reach our plates, contributing to greenhouse gas emissions. By producing food locally, vertical farms can drastically cut down on the carbon footprint associated with food distribution. This makes them a key player in the fight against climate change, offering a sustainable alternative to conventional agriculture. Looking ahead, the possibilities for vertical farming are immense. From leafy greens and herbs to fruits and even grains, these skyscrapers could one day supply a significant portion of a city's food needs. Some designs even incorporate aquaponics, where fish and plants are grown together in a symbiotic system, further enhancing sustainability. As technology continues to advance, we may see vertical farms that are not only functional but also beautiful, with lush green facades that transform urban skylines. Vertical farming skyscrapers represent a bold step forward in reimagining how we grow and consume food. By integrating agriculture into the fabric of our cities, they offer a solution to some of the most pressing challenges of our time: food security, land scarcity, and climate change. And with that, let's move on to explore another innovative concept that's pushing the boundaries of what's possible in architecture. Now, let's shift our focus to a groundbreaking development that's transforming the very foundation of architecture: lightweight and ultra-strong materials. As cities grow taller and more complex, the demand for materials that can support ambitious designs while remaining sustainable has never been greater. Enter materials like graphene and carbon fiber, which are redefining what's possible in construction. Graphene, often hailed as a wonder material, is incredibly thin yet stronger than steel. Its unique properties make it an ideal candidate for creating structures that are both lightweight and exceptionally durable. Imagine skyscrapers that soar higher than ever before, supported by materials that are not only strong but also incredibly efficient. This means less material is needed overall, reducing the environmental impact of construction while enabling architects to push the boundaries of design. Carbon fiber is another game changer in the world of architecture. Known for its high strength-to-weight ratio, it's already being used in industries like aerospace and automotive. In architecture, carbon fiber allows for the creation of slender, elegant structures that can withstand extreme forces, from high winds to seismic activity. This opens up new possibilities for building in challenging environments, such as earthquake-prone regions or areas with harsh weather conditions. One of the most exciting aspects of these materials is their potential to revolutionize skyscraper design. By using lightweight and ultra-strong materials, architects can create taller buildings with less structural bulk, freeing up valuable space for innovative features like green terraces, sky gardens, or even entire vertical neighborhoods. These materials also make it easier to prefabricate components off-site, speeding up construction timelines and reducing on-site waste, but the benefits extend beyond just height and efficiency. Lightweight materials like graphene and carbon fiber also contribute to sustainability. Their strength and durability mean that structures built with these materials have longer lifespans, reducing the need for frequent repairs or replacements. Additionally, their lightweight nature reduces the energy required for transportation and installation, further lowering the carbon footprint of construction projects. Looking ahead, the integration of these materials into architecture could lead to entirely new forms of design. Imagine buildings with intricate, lattice-like facades that are both visually stunning and structurally sound, or bridges that span vast distances with minimal support. The possibilities are as limitless as the imagination of the architects who wield these materials. Lightweight and ultra-strong materials like graphene and carbon fiber are not just changing the way we build, they're redefining what's possible. By enabling taller, lighter, and more resilient structures, they're paving the way for a future where architecture is as innovative as it is sustainable. And with that, let's move on to explore how immersive virtual reality spaces are shaping the next frontier of architectural design. Now, let's step into a world where the boundaries between reality and imagination blur: immersive virtual reality spaces. Virtual reality, or VR, is no longer just a tool for gaming or entertainment. It's becoming a revolutionary force in architecture, transforming how we design, experience, and interact with spaces. Imagine walking through a building that hasn't even been constructed yet, or attending a meeting in a virtual office that feels as real as the one down the street. This is the power of VR in architecture. One of the most exciting applications of VR is in the design process itself. Architects can now create fully immersive 3D models of their projects, allowing clients and stakeholders to explore every detail before a single brick is laid. This not only enhances communication but also reduces the risk of costly mistakes. For example, a client can virtually walk through a proposed office space, experiencing the lighting, acoustics, and layout in real time. This level of immersion helps everyone involved make more informed decisions, ensuring the final design meets expectations. But VR's potential goes beyond just design. It's also transforming how we use architectural spaces. Imagine a classroom where students can take virtual field trips to ancient ruins or explore the surface of Mars without leaving their seats. Or think about a workspace where employees can collaborate in a virtual environment, no matter where they are in the world. These immersive experiences are not only engaging but also incredibly practical, breaking down physical barriers and opening up new possibilities for education and work. Entertainment is another area where VR is making waves. Picture a concert hall where the audience can experience performances in a completely virtual setting, with visuals and sounds that transport them to another world. Or consider a museum where visitors can step into historical scenes, interacting with artifacts and environments in ways that were never before possible. These immersive spaces are redefining how we experience culture and entertainment, making them more accessible and engaging than ever. The integration of VR into architecture also has the potential to democratize design. With VR tools becoming more affordable and accessible, even small firms and independent architects can create stunning virtual models. This levels the playing field, allowing more voices to contribute to the built environment. Additionally, VR can be used to engage communities in the design process, giving people a chance to experience and provide feedback on projects that will shape their neighborhoods. As we look to the future, the possibilities for VR in architecture are virtually limitless. From designing smarter cities to creating spaces that adapt to our needs in real time, VR is poised to become an essential tool for architects and designers. It's not just about building structures, it's about creating experiences that enrich our lives in ways we're only beginning to imagine. And with that, let's turn our attention to the final concept on our list: regenerative architecture, where buildings don't just coexist with nature but actively restore it. Now, let's shift our focus to a concept that takes sustainability to the next level: regenerative architecture. Unlike traditional sustainable design, which aims to minimize harm to the environment, regenerative architecture goes a step further by actively restoring and revitalizing ecosystems. Imagine buildings that don't just coexist with nature but actively contribute to its healing and growth. This is the essence of regenerative design, and it's reshaping how we think about the relationship between architecture and the environment. One of the most inspiring examples of regenerative architecture is the use of buildings to clean the air. Picture a skyscraper covered in bioreactive materials that absorb pollutants and release clean oxygen. These materials, often embedded with algae or other microorganisms, act like a giant air purifier, improving the quality of the surrounding environment. In cities where air pollution is a major concern, such structures could play a crucial role in creating healthier urban spaces. Water purification is another area where regenerative architecture is making a difference. Buildings can be designed with integrated systems that collect, filter, and reuse rainwater, reducing the strain on municipal water supplies. Some designs even incorporate wetlands or green roofs that naturally filter water while providing habitats for local wildlife. These features not only enhance the building's sustainability, but also contribute to the restoration of local ecosystems. Regenerative architecture also embraces the idea of creating habitats within urban environments. For instance, vertical gardens and green walls can support biodiversity by providing nesting spaces for birds and insects. These living structures not only beautify the cityscape, but also help rebuild ecosystems that have been disrupted by urbanization. By integrating nature into the built environment, regenerative architecture fosters a harmonious relationship between humans and the natural world. Another exciting aspect of regenerative design is its focus on circular systems. Instead of following a linear model of construction and demolition, regenerative buildings are designed to reuse materials and resources in a continuous loop. For example, a building might be constructed using recycled materials that can later be repurposed at the end of its life cycle. This approach minimizes waste and ensures that resources are used efficiently, creating a more sustainable future. The potential of regenerative architecture extends beyond individual buildings to entire communities. Imagine neighborhoods where every structure contributes to the restoration of local ecosystems, from parks that clean the air to streets designed to manage stormwater naturally. These regenerative communities could serve as models for sustainable urban development, demonstrating how cities can thrive while giving back to the environment. As we look ahead, regenerative architecture offers a vision of a future where buildings are not just passive structures but active participants in the health of our planet. By designing spaces that restore ecosystems, we can create a built environment that supports both human well-being and the natural world. This approach challenges us to rethink our role as architects and designers, inspiring us to create spaces that leave a positive legacy for generations to come. And with that, let's explore some real-world examples of regenerative architecture in action. Now, let's take a closer look at how regenerative architecture is being brought to life through real-world projects that are making a tangible difference. One standout example is the Bosco Verticale, or vertical forest, in Milan, Italy. This pair of residential towers is covered in over 900 trees and thousands of shrubs and plants, creating a vertical ecosystem that absorbs carbon dioxide, produces oxygen, and supports biodiversity. The buildings not only improve air quality but also provide a habitat for birds and insects, demonstrating how urban spaces can actively contribute to environmental restoration. Another remarkable project is the Bullitt Center in Seattle, often referred to as the greenest commercial building in the world. Designed to be fully self-sufficient, the Bullitt Center generates its own energy through solar panels, collects and treats rainwater for all its needs, and uses composting toilets to minimize water waste. The building's materials were carefully selected to avoid harmful chemicals, and its design prioritizes natural light and ventilation, reducing energy consumption. This project serves as a model for how regenerative principles can be applied to create buildings that give back to the environment. In Singapore, the Khoo Teck Puat Hospital showcases how regenerative architecture can enhance both environmental and human health. The hospital features lush greenery throughout its design, including rooftop gardens, healing gardens, and green walls. These elements not only improve air quality and reduce the urban heat island effect, but also provide therapeutic spaces for patients and staff. The integration of nature into the hospital's design has been shown to speed up patient recovery times and improve overall well-being, proving that regenerative architecture can have a profound impact on both ecosystems and people. Moving to the Netherlands, the Park 2020 development in Hoofddorp is a prime example of a regenerative community. This mixed-use complex is designed to operate as a closed-loop system, where waste from one process becomes a resource for another. For instance, organic waste from restaurants is composted and used to fertilize green spaces, while rainwater is collected and reused for irrigation. The buildings are energy efficient and constructed with sustainable materials, creating a community that actively contributes to environmental restoration. Finally, the Eden Project in Cornwall, England, is a groundbreaking example of regenerative architecture on a large scale. This educational and environmental complex features massive biomass that house diverse plant species from around the world. The project not only educates visitors about the importance of biodiversity, but also demonstrates how architecture can create environments that support and restore ecosystems. The biomass are constructed with lightweight, durable materials and are designed to minimize energy use, showcasing the potential for regenerative design to inspire and educate on a global scale. These case studies highlight the incredible potential of regenerative architecture to transform our built environment, from improving air quality and supporting biodiversity to creating self-sufficient communities. These projects prove that architecture can be a powerful tool for environmental restoration. As we continue to face global challenges like climate change and urbanization, regenerative architecture offers a hopeful vision for a future where buildings actively contribute to the health of our planet. As we marvel at the incredible potential of regenerative architecture and other futuristic concepts, it's important to acknowledge the challenges that stand in the way of bringing these visionary ideas to life. One of the most significant hurdles is funding. Many of these projects require substantial financial investment, whether it's for advanced materials, cutting-edge technologies, or innovative construction methods. Securing the necessary funding can be difficult, especially when the benefits of these projects, such as long-term environmental restoration or energy savings, may not be immediately visible to investors or stakeholders. Convincing governments, private investors, and the public to prioritize these projects over more traditional, short-term solutions remains a critical challenge. Another obstacle is public acceptance. While futuristic architecture often captures the imagination, it can also face resistance from communities accustomed to more conventional designs. People may be skeptical of new technologies or unfamiliar building styles, fearing they could disrupt the character of their neighborhoods or fail to meet their practical needs. For example, vertical forests or floating cities might seem like science fiction to some, leading to hesitation or outright opposition. Architects and developers must work to educate and engage the public, demonstrating how these innovative designs can improve quality of life and address pressing global issues like climate change and urbanization. Technological limitations also play a role in slowing the adoption of futuristic architecture. While advancements in materials, artificial intelligence, and renewable energy are accelerating, many of these technologies are still in their early stages or require further refinement to be viable on a large scale. For instance, self-healing materials or energy-generating facades may work well in controlled environments but face challenges when applied to real-world conditions. Additionally, integrating these technologies into existing infrastructure can be complex and costly, requiring collaboration across industries and disciplines. Regulatory barriers further complicate the picture. Building codes and zoning laws designed with traditional construction in mind often lag behind the rapid pace of architectural innovation. This can create bureaucratic roadblocks that delay or even prevent groundbreaking projects from moving forward. Architects and policymakers must work together to update regulations, ensuring they support rather than hinder the development of sustainable and futuristic designs. Despite these challenges, the potential rewards of overcoming them are immense. By addressing funding gaps, fostering public trust, advancing technology, and reforming regulations, we can unlock a future where architecture not only meets our needs but actively contributes to the health of our planet. The journey won't be easy, but the vision of a better built world is worth the effort. As we look ahead, collaboration, creativity, and perseverance will be key to turning these futuristic concepts into reality. Now, as we turn our gaze toward the future, it's clear that the architects of tomorrow will play a pivotal role in shaping the world we live in. Education stands at the heart of this transformation. The next generation of architects must be equipped not only with technical skills, but also with a deep understanding of sustainability, technology, and human-centric design. Universities and design schools are already beginning to integrate these principles into their curricula, encouraging students to think beyond traditional boundaries and embrace interdisciplinary approaches. By fostering creativity and critical thinking, education can empower young architects to tackle the complex challenges of our time, from climate change to urbanization. Innovation, too, will be a driving force in the evolution of architecture. The architects of tomorrow must be fearless in experimenting with new materials, technologies, and design philosophies. From bioengineered materials to artificial intelligence, the tools at their disposal are more advanced than ever before. But innovation isn't just about adopting the latest gadgets, it's about reimagining how we build and live. It's about creating spaces that adapt to our needs, heal the environment, and inspire awe. By pushing the boundaries of what's possible, architects can lead the way in creating a more sustainable and resilient future. Collaboration will be equally essential. The challenges we face are too vast for any one person or discipline to solve alone. Architects must work hand in hand with engineers, scientists, policymakers, and communities to bring their visions to life. This spirit of collaboration extends beyond professional partnerships. It's about listening to the needs and aspirations of the people who will inhabit these spaces. By engaging with diverse perspectives, architects can create designs that are not only innovative but also inclusive and meaningful. The architects of tomorrow have the opportunity and the responsibility to shape a world that is more equitable, sustainable, and beautiful. Through education, innovation, and collaboration, they can turn the boldest ideas into reality, leaving a lasting legacy for generations to come. As we look ahead, one thing is certain: the future of architecture is in capable hands, and the possibilities are limitless. As we bring our journey through these 25 groundbreaking concepts to a close, it's impossible not to feel a sense of awe and optimism for what lies ahead. From vertical forests that breathe life into our cities to floating cities that adapt to rising seas, each idea represents a bold step toward reimagining the world we live in. These concepts aren't just about building structures, they're about creating spaces that heal, inspire, and connect us to one another and to the planet. They challenge us to think beyond the limits of today and envision a future where architecture is not just functional but transformative. Imagine a world where buildings generate their own energy, where materials repair themselves, and where entire cities are designed to restore ecosystems rather than deplete them. Picture homes that adapt to your needs, public spaces that come alive with holographic displays, and communities that thrive underground or even in space. These aren't distant dreams, they're possibilities within our reach, driven by innovation, collaboration, and a shared commitment to sustainability. The architects of tomorrow are already laying the groundwork for these ideas, and their work reminds us that the future is not something we inherit but something we create. But this future isn't just for architects to shape, it's for all of us. Every choice we make, from the materials we use to the spaces we inhabit, has the power to influence the world around us. By embracing these concepts and advocating for their implementation, we can all play a part in building a better, more sustainable future. Whether you're a designer, a policymaker, or simply someone who cares about the world we leave for future generations, your voice matters. Together, we can turn these inspiring ideas into reality. So, as we wrap up, I encourage you to keep imagining, keep questioning, and keep pushing for change. The future of architecture is not just about buildings, it's about the lives they touch, the communities they nurture, and the planet they protect. Let's dream big, act boldly, and build a world that inspires us all. If you found these ideas as exciting as I did, don't forget to like this video, subscribe to the channel, and hit the notification bell so you never miss out on exploring the future with us. Thanks for watching, and here's to a better built